Hello, algebra. I just wanted to say hi. I just wanted you to see my face. Don't forget what I look like. Um, I miss you all, and I wish that we were in class together. But here we are, right? A new adventure in our lives. So we're going to start some notes, and we're going to work through them. And just know that I miss you. And I hope you miss me too, even just a little bit. Hope you miss math. I miss nerding out with you in person, but we're going to nerd out together in our notes. All right, so I'm going to flip this around and we're going to start taking notes. All right. Oh, look. There's Butch. Say hi, Butch. They got their own little bed in here so that they can participate in math class also. All right, is that good? Okay, here we go, guys. Well, let's take some notes. So today, we're continuing into this factoring. We started with factor squares, we did prime factorization, we did greatest common factor, and we did factoring at the greatest common factor, so we undistributed, right? We practiced the skill of taking the answer that we've been working all year on finding, and we're going back and trying to find the original problem. We're undistributing. So today we're going to factor by grouping. We're going to factor by grouping. And factoring by grouping means that I'm gonna make groups inside of this polynomial. Oh, my coffee's already almost cold. All right, practicing factoring by grouping, and then we're gonna practice again. You guys, page 100. 100 pages of notes. This is insane. So let me get my pens ready. And here we go, page 99. Factor by grouping. All right, so to factor by grouping, the skill that we're working on today, it is only used, so every single problem we are going to encounter today is going to be very specific. They're all going to look very similar to each other. It only works for 4-term polynomials. So it's very specific. It has to be a 4-term polynomial. If it's a 5-term polynomial, it's not going to work. If it's a trinomial, not going to work. We have to have 4 terms in our polynomial. And so you need to make sure, is it simplified, right? So as long as it is a simplified polynomial and it has 4 terms, these are the skills that we're going to work on. So there are 5 questions, 5 steps that we're going to go through. So the first one, which is always going to be our first step of just, is the leading coefficient negative? And if that leading coefficient is negative, you factor out a -1, which means you just change everything. Right? Every sign changes when you factor out that -1. Because we have to have that -1 factored out. That leading coefficient needs to be positive, and that's sometimes our sticking point when we're doing our factoring, is that we start to factor, we forget to check that -1 value, or that negative leading coefficient value, and we start working and all of a sudden nothing works out and we get confused and it's frustrating. Well, if that leading coefficient is negative, your factoring gets screwed up. So you have to take that leading coefficient and make it positive, which means every term is going to change. After you check, right, it might be positive. Maybe you skip step 1. So then we say, is there a GCF for all terms? right? Is there a GCF for all of the terms? Are all of the terms positive? Can we divide everything by 2? Do they all share at least one x? Can we take out an x, right? So you have to look and see, is there a GCF? Because that's another sticking point. Sometimes we get to this number, and especially if they're really big values, like if we're working with like numbers above 100, or even sometimes numbers that are, 50 and above, if all of those values are the big values, right? All of our coefficients are big values, or all of our variables have large exponents with them, there's probably a GCF that we can take out to make our life a little bit easier when we start doing the actual factoring of the grouping. So just remember that you're looking for coefficients and or, right? Maybe it's both, maybe it's not. Coefficients and variables. And maybe there's not a GCF, right? Maybe there's not something that we can take out. The first one that we're going to do doesn't have a leading negative coefficient and doesn't have a GCF. And so we just skip those steps. If it doesn't have those pieces that we're looking for, then skip them. But you need to ask. Those are the order of the questions that you need to ask. So then step 3 is that we're going to split the polynomial in half. And this is why it's really important. It has to be a 4-term polynomial because we're splitting it in half. If it was a 5-term polynomial, I wouldn't be able to split it in half because I'd have an uneven, right? 5 is not divisible by 2. Now, you can't split a 6-term polynomial in half. It only works for 4 terms. So we're going to split it in half. So we have 4 terms, right? And we have now 2 in the front and 2 in the back. I'm going to draw a physical line that splits it in half. And then step 4 is to factor each half, which is find the GCF for each half, right? So we're going to factor each half. And when you have a binomial now, right? It was 4 terms. We split it in half. Now it's 2 terms, 2 on each side. When you have 2 terms, we factor by finding the GCF. And then our answer is going to look like this. And it looks a little confusing now, but it will make sense once we do an example. So our answer is going to be a binomial times a binomial. And so this is what it looks like. It looks like the GCF from the first half, right? The GCF from the first 2 plus the GCF from the second 2. Remember up here, we split it in half, so we have a front side and a back side. This is going to be the GCF of the front side plus the GCF of the second half, the back side. And then this one is going to be what I'm calling the leftovers. Oops, overs is spelled with a V, not a W. And I'm going to show you what that leftover means. I promise it will start making sense as we progress through the problems. All right, so let's start out slow. Examples. 5x to the third minus 4x squared minus 30x plus 24. It's in standard form, which is key. There are no like terms that can be combined. So now let's question. Is the leading coefficient negative? No. Is there a GCF for all of the terms? Coefficients and or variables. All right, so 5 is prime, so it can only be divided by 1 and 5, right? They don't share anything, right? So we don't have any common factors. And variables, there's not a variable here, so there's no GCF. Step 3, split it in half. So I have 4 terms. I'm going to split it in half just like this. Remember that minus sign belongs to the negative or to the 30, right? It becomes now negative 30 instead of minus 30. Same type of skill. Step 4 is to factor each half. So I'm going to look at the front half. What do 5x to the third minus 4x squared? What is the GCF of this binomial? Well, the coefficients don't share anything. They can't both be divided. It's 1. But they do have at least 2 x's. So do I have a sticky note? I used to. Well, I do. I'm going to cover that side up, just so we can talk it through. So I'm going to factor this side. So 1x squared. You don't need the 1 if you don't want it. And what's left behind? 5 divided by 1 is 5. X to the third divided by x squared is x. Negative 4 divided by 1 is negative 4. And x squared divided by x squared cancels out. So I factored the front half. Now I'm going to go to the back half. I'm looking and I'm seeing, oh, in this binomial now, my leading coefficient is negative. So I'm going to take out a negative, right? I'm going to take out a negative 1 and change it to 30x minus 24. What do 30 and 24 share? If you don't know off the top of your head, go back to your factor squares. 30 is right here, 24 is right here. What's the biggest value that they can both be divided by is 6. So their greatest common factor is 6. So I'm going to factor out a 6, which is going to get multiplied by that negative 1, which is out front. 30x divided by 6 is 5x. Negative 24 divided by 6 is negative 4. So the answer is negative 6, 5x minus 4. Now, the answer to our problem, if you notice, looking at this, I have a GCF from the first problem, which is right here. So x squared plus the GCF from the second problem, which is negative 6. So you could put plus negative 6, or you could just write minus 6. GCF from the first, GCF from the second. And then what happens, if you notice, it says up here the leftovers. When we factored out the GCF, our leftovers, what remained, what goes inside the parentheses still, matches. And since they match, I know that I did it correctly. So here's my solution. I just factored this 4-term polynomial. We're going to keep practicing if it doesn't make sense right away. And then I will also be available for questions if you have them, right? So we're just going to continue working through these problems. Oh no, now my coffee is completely cold. I'll survive. Excuse me, 35x to the third plus 245x squared. Oof. Minus 49x minus 343. All right, huge numbers, right? We're talking, no one knows the factors of this and the factors of this, right? These are gigantic. So let's go through our steps and see where it leads us. Is the leading coefficient negative? No. Skip step 1. Is there a GCF for all of the terms? Probably. I mean, I've got these huge values. There's probably a GCF. So since I don't know the factors of 245 off the top of my head or 343 off the top of my head, I'm going to stick with the numbers that I can work with right now. So I'm going to go to 35 and 49. Maybe you already are thinking about it and know that they have a GCF. So where's 49? 49 is 7 and 35, 7. So let's test it, right? And this is where I'll use my phone just because most of you guys are using, oh, that's the wrong thing. Using your phones. Oh my goodness gracious, guys. Oh, there it is. Whew. Miss Warshaw's texting me, guys. All right, so here we go. 245, 343. Let's see, 245 divided by 7 is divisible, and 343 divided by 7, oops, 343 divided by 7 is also divisible. Perfect. So let's factor out a 7. Let's get these numbers that are more manageable. Any variables? No. 35 divided by 7 is 5 with an x to the third at the end. Plus, oh, I already forgot. What was 245 divided by 7? 35. 35x squared. Negative 49x divided by 7 is negative 7x. Negative 343 divided by 7 is negative 49. All right, those numbers look more manageable. Excellent. All right, so we are going to split it in half. Step 3, split it in half. Remember, this minus sign belongs with the 7. And now we're going to factor the front. So I've got this leading coefficient of 7 that's going to come down here. I can't forget about it. But now let's factor this. So 5x to the third plus 35x squared. What's their greatest common factor? Again, go to those factor squares. If you can't figure it out, go to the factor squares. 35 and 5, well, they both share a 5 in their box. So I can take out a 5 and x squared. They both at least have an x squared, which leaves behind 5 divided by 5 is 1. X to the third divided by x squared is x. Plus 35 divided by 5 is 7. X squared divided by x squared cancels out. Let's go to the second half. Is my leading coefficient negative? You betcha. Take out the 1, which leaves behind 7x plus 49. What is the greatest common factor of 7x and 49? Is anybody? 7. So negative 1 times 7 is my greatest common factor. 7x divided by 7 is x. 49 divided by 7 is positive 7. We know we did it correctly because our leftovers match, right? So the GCF of the first problem, 5x squared, and the GCF of the second problem is negative 7. And then my second binomial are the leftovers. But don't forget, we had a GCF at the beginning of this problem, which was 7. Again, we are just going to keep practicing. I will also be available for help if you need it during this week and next week. We just have to, one of those things that we're just going to practice, and then it clicks one day and you're a professional factorer. All right, we're going to do 2 more practice problems. I'm going to put them up. If you would like to try them on your own, pause the video once you have them written down, and then see if you made your way through the problems and were able to do them without help. That's a great idea. Or you can just follow along, right? So there's the first one, and then I'll skip down here. Can you see that? Yeah. X to the third minus 3x squared plus 8x plus 4. All right, so these are going to be your 2 practice problems. If you want to pause the video now, try them on your own, then start it up, and then follow through and see if you did it right. I'm going to talk through the problems, so here we go. First question, is the leading coefficient negative? Nope, so I skipped that step. Is there a greatest common factor? So let's see, 35, 30, 14, and 12. Let's see, 35 is 5 and 7, cannot be divided by 5 and 7, so I'm stopped, right? I just check, and the moment that those 2 factors don't work in the next one, they're off the table. So no, there's not a greatest common factor. So now I'm going to split it in half. My next step from splitting in half is to factor the front side. 35b to the third minus 30b squared. Those greatest common factors, I believe, are 5. Where are they? 30 and, what was it, 35? Yeah, 30 and 35. The greatest common factor is 5. So I'm going to take out a 5. I'm also going to take out a b squared because there are 3 here, but there's only 2 here, so the greatest that they share is b squared. Leaving behind, 35 divided by 5 is 7. B to the third divided by b squared is b. Negative 30b squared divided by 5b squared. Negative 30 divided by 5 is negative 6. And b squared cancel out. I'm looking over here on the back side. 14b, it's positive, that's exciting. 14b minus 12. So they are both even. 14 can be divided by 2 and 7. 12 can't be divided by 7, but it can be divided by 2. Let's see, is there anything else? Double check. If you're not sure, we're going back. 14 can only be divided by 2 and 7, so it's just 2. 2 is our greatest common factor, which leaves behind 14b divided by 2 is 7b, and negative 12 divided by 2 is negative 6. Now, some of you may be saying, okay, Mrs. Long, I want these to match, right? So maybe when you're doing it, we'll talk this through the next time, instead of trying to figure out the greatest common factor, you're looking for this number to be left behind. So maybe you just divide by this coefficient over here. We'll talk through it in a second. Maybe that'll work. Let's see. Do they match? They sure do. So my solution, my answer is the greatest common factor from the first plus, this is positive, the greatest common factor from the second, and then what we're calling fondly the leftovers. Oh, it got blurry. There we go. All right, let's try this last one. Question number 1, is the leading coefficient negative? Ooh, it is, right? I'm going to take out the negative 1, and I'm going to leave behind 6x to the third plus 3x squared minus 8x minus 4. And I'm going to draw this arrow down just so that I don't forget that I had a leading negative coefficient, so that has to go into my answer. All right, is there a greatest common factor? 6 can be divided by 1 and 6, or 2 and 3. 3 can be divided by 1 and 3. So maybe 3. Can 8 be divided by 3? No. No greatest common factor. Step 3, split it in half. Don't forget that minus belongs to the 8. Step 4, factor the front half. So 6x to the third plus 3x squared. Greatest common factor there is 3x squared. I know because 6 can be divided by 2 and 3, and 3 can be divided by 3 because it's prime. So I have to focus on these factors of a prime value to see if they also work with that composite number. 6x to the third divided by 3x squared is 2x. And 3x squared divided by 3x squared, do not put 0. It is 1. If it was 0, it disappears, and I don't want that place value to disappear, right? I need a number there. It's the number 1. So what I was talking about in that previous one, this leftover, right? I need this leftover to match over here. So I need 2x plus 1 over on this side. So I'm going to use that knowledge of getting 2x plus 1 on this side to help me factor. Is the leading coefficient negative? You betcha it is. Meaning I take out the negative, leaving behind 8x plus 4. Now, remember, we just talked about this. I want this and the future one down here to match. So what do I do? What can I take away from 8x to make sure I leave behind 2x? If I have 8x and I want 2x to be left behind, I know that the greatest common factor that I'm going to have to take out is 4. So -1 times 4. 8x divided by 4 is 2x. And 4 divided by 4 is 1. And now they match. Meaning my solution is the greatest common factor from the first one, 3x squared, right? The greatest common factor from the second one, 1 times 4 is -4. My leftovers are 2x plus 1. And then I drew this arrow to remind me I had a value I took out at the beginning, so I need to put that -1 back in front. All right, keep trying. You can do it. Follow these steps. Get really comfortable with going through step by step and asking yourself the answers, these questions, and answering them. Again, I will be here if you need help. We will have some time that we can get on and work together. And I know you can do it. You're going to need some scratch paper probably to go through and do this. But it's explained step by step through these 5 directions, right? You can do it. Reach out if you need help. And good luck. Bye.